Buongiorno a tutti e benvenuti a questo nuovo Ocrim webinar dedicato alla rassegna Automation and Maintenance, dedicato quindi alla gestione e al corretto funzionamento dei macchinari ad uso moritorio. A questo punto...
So I think we can start. I don't know if you know me, but for those of you who don't know me, I'll introduce myself. My name is Nicola Riboldi. I'm a mechanical engineer. I've been working for Ocrim for a few years, and I work for the technical office here in Cremona, and I deal with designing of Ocrim machines. The theme of today's event is the future is at mobile. So we will be talking about the at mobile project, which is about the smart management systems for Ocrim machines. And in particular, we will have a look at the tablet management system applied to our RMX machine, which is a roller mill. You can see it behind me. And in order to better understand this topic, I would like to invite you the two technicians that will talk about these different aspects, Luca and Ivan. Hello, Luca. Hello, Ivan. Welcome. Luca has worked for Ocrim as automation technician, web and mobile developer, and he is our reference for the projects that require tablets. Ivan has worked for Ocrim as an electronic and electrical engineering technician, and he's also a PLC programmer. Today's event we have two main sessions or parts. In the first part, Luca will be talking about how this project was conceived, how it started. So he will talk about web architecture, and he will talk into detail about the procedure of our app, starting with the interface, then network diagnostics, machine modules, and new features, especially NFC and QR code. In the second part, even, we'll carry out a practical demo about how to manage and control the RMX roller mill that you see behind me through a tablet. So before I leave the floor to Luca, I would like to remind you that this event will last about 45 minutes. And before we actually finish this event, we will have a moment to answer your questions. You can send them through our chat. Anyway, if you have further questions, even after the event, you can send us an email at conferenceroom@ocrim.com, and it will be a pleasure for us to answer to your questions. So I think that we can leave the floor to Luca. Thank you, Nicola. Hello, everyone. My name is Luca Fiorani. I'm an automation technician for Ocrim, and I deal with tablet projects mainly. At Mobile, our tablet app was conceived as a tool for remote control for roller mills panels. It was developed over the years with different kinds of machines like dozers, wetting machines, scales, but we also added other modules that we will have a look at later on. This app started as a modular software, so it is easy to set up according to the client's needs. If we're talking about roller mills, then we will have specific modules depending on the kind of machine. So I would move on to showing you the tablet screen. So here, what you can see is the Mobile homepage. On the left-hand side, you can see the list of our machines, which is a list of the machines controlled by our tablet. You can see, for example, that in this plant, we have RMX roller mills. We have two machines. We have an A and a B side. And on top of that, we can see that the tablet is giving us some information about the state of the machines. For example, roller mill 301 has a connected A side, but the B side is in alarm. It's flashing red, as you can see, while a yellow color would have represented a warning in this case. While the icon that you can see below, it means that the machine is not connected or there's a problem with the connection. If we move to the right-hand side, you can see the shortcuts. You can select the pages that you want to access. For example, settings in this case. This way we can directly access this page through the home page. On the top right side, sorry, you have another menu under which you can find settings. And here you can open this page and change the theme. You have, for example, dark, Ocrim, or light, which is the default theme, the language, in this case it's English, and some other settings about vibration, for example. Then below that, below settings, we have machine locks, which are a safety feature that was implemented so as to allow the operator to act on the machine without the help of other operators. Let's analyze a line from this page. For example, we have roller mill 301, A side, which is locked by a tablet device from 338 until 341, and it is unlocked by a user. So we have different unlock causes. For example, the user in this case has manually changed the
in modo automatico dopo 24 ore di inattività.
Page. There are other causes for unlock. For example, automatic one after 24 hours of lack of activity, then system, and in case an Ocrim technician has manually disconnected the machine. Below this section, we have the profile page and logout page. If we go back to the home page, on the top left corner, you see that we have a side menu. We have a connection to the profile, to the home page, and two pages which are in between the module and the machine. The alarms history page, where you can see all the list of the alarms occurred with all the machines, and you can filter it depending on the machine or kind of alarm. But what's more interesting is the web diagnostic page. Here you can see a graphic representation of the web architecture. So we have the tablet connected to the server, which is in turn connected to the PLC. And then from there, we have two connections. One, which is the one connected to roller mill 301, which is okay, and it's shown in green. And the other one, 302, which is not okay, and it's shown in red. And thanks to this graphic structure, we can understand the different connections between the server and the tablets. There's a network of access points that allows coverage, Wi-Fi coverage of the plant. Talking about connectivity, on the top right corner, we have two icons, the Wi-Fi icon that is telling us that the tablet is connected to the right Wi-Fi connection. If we had a red icon, then that would mean that there's a problem with the connection or the Wi-Fi is not active. A yellow icon would mean that the tablet is connected to a Wi-Fi network, but it's not the right one. So in this case, the tablet would not be able to connect to our server. Talking about these, on the right-hand side, you can see the server icon. So the device is connected. So it's showing green. If it was red or yellow, that would mean that the tablet is not connected or is trying to connect still. So I think we can move on with the side menu. You can see that there's another section called System Module, which is about authorization. So you can see the users page where you can define the new users using their names, usernames and passwords. Then the groups page, for example, we have the guest group and the administrators group. Then the connection or association between these kind of figures, so users and groups. In this case, we have admin as a user, which is part of the administrators group. And then we have two pages for the permits. The first page is divided into the different pages that the user can select. In this case, I selected settings, so the user can edit the different permits or authorizations. On the other hand, on the final page, we can choose the group, the desired group, and view all the permits from this group. Now let's go and have
Un modulo macchina, l'RM.
a look at machine modules. We decided to choose just one module in this case. At mobile, as I said, also manages wetting machines, dosers with the FC module, and with the WG module, it also manages scales, for example. Then we have this page with the representation and graphic representation of the main state of our machines of this macro category. Here indicating to us. So in the case of the roller mill 302, we see that it's not connected. In the other case, so on the left-hand side, you can see that it's not, there's an alarm. And we can also analyze the absorption percentage of the machine and the tube. The machine modules can have specific pages. In this case, we have just one, which is the roller mill commands, from which you can send signals or commands to different roller mills at the same time. Other kinds of pages or specific pages for machine modules might be, for example, about graphs that were drawn up thanks to the information sent by certain sensors. Let's now talk about other kinds of modules. In the last few years, and quite frequently, ETMobile gets updates or has been getting updates about feedback from the machines. In this case, we have tried to work on innovative technologies like NFC and QR codes. QR codes were used within a module called mobile control. Traditionally, this name was given to a physical panel that was connected to the machine via cable, and this would allow the operator to command or to control the motors for maintenance purposes. In this case, the module would allow the mobility of Wi-Fi and tablets. And in this way, we take a step forward because it implements an authorization for motors. So The basic idea is to place some QR codes in specific areas on the plant so that the operator can access information about that specific area where the QR codes are. So the operator just needs to scan the code and get the information needed. Talking about NFC, since Miller's requested this kind of feature for quite a long time, so they asked us to access in an easier way the panel of a certain machine. So we decided to use this kind of technology, and we applied it to certain areas of our machines. For example, here we have a roller mill, as we said before. In this case, we would have placed the tag or label exactly where the traditional panel used to be. In this case, the application was not possible because we have a different kind of machine. So the tag was placed just on the right-hand side. So in order to access the machine panel, I just need to place the tablet close to the machine, and and a page will open with the information. This kind of feature works even if we're not using the @mobile app. I think I've done, so I will leave the floor to Ivan that will talk to you about the roller mill. So here you can see the feed roller that tells us the quantity of product that will fall within the milling passage. This roller is put into rotation by different components, and the movement is transmitted through a bell. So the machine has an RPM control, which is a standard control from the company. The feed roller speed is selected by the operator through two different modes or features. Okay, you can see the screen here. The first one called K, which is a constant mode in which the operator specifies the speed set point for our RPM, and a more advanced and automatic mode in which the operator enters the level set point that he wants to keep in the tube. So the controller on board of the machine, having the feedback from the level probe, knows how much product there is in the tube, and he will be able to calculate the RPM of our feed roller. So once the feed roller has dosed the product, this falls into the passage, into the milling passage, which is made of a couple of cylinders that is put into rotation by an asynchronous motor, which is connecting to a transformer. And these transformer signals, which is 420 milliamperes, is received by the machine. So the miller that will use the machine will have the data about absorption in order to asset the movement of cylinders and maybe adjust the gap. The gap is the distance between the two cylinders. Another very important component is the pneumatic cylinders that you see in this position and on the different side as well, that allow the adjustment of the two milling cylinders. This way, it will be possible to keep the motor on even when the product is not there, is not present. The movement of the pneumatic cylinders is monitored by a sensor that you can see on the screen. This sensor detects the position of the shank within the cylinder and ensures the right functioning of this one. So starting the milling process is about starting the feed roller and the engagement of the two cylinders. In order to start milling, there are two requirements that need to be met. The first one, the motor must be on, of course, and the machine knows that it's on thanks to the detection of the absorption by the motor. And the second condition or requirement is that the machine gets a signal, an activation or enable signal, which can be an electric one or a signal or a different signal, depending on the version of our machine. Once we meet these requirements, the operator can select two modes, two starting modes on the tablet. One is manual or forced. So you can press this button every time we want to start milling, and an automatic mode. This automatic mode that I've just selected is guaranteed by the presence of a presence sensor for the product, which is placed here. This sensor detects the presence of our product, and it gives us more detailed and precise information or data about the product. In this position, instead of having a touch panel, the traditional touch panel, in this case, we have a LED display which shows the milling motor absorption so that the operator can get the main piece of information even without a tablet. And there's a button to enable or stop milling in case the operator doesn't have his tablet with him. I would like now to analyze the tablet app. These are the roller mill pages. This is the runtime page where we analyze the state of the different components. So milling motor, then gear motor, and then the last one is the hopper or tube. For our milling motor, we can see the absorption in ampere and the percentage absorption. For gear motor, we can see the RPM and the speed percentage. And for the hopper, we have the level of product detected by the probe. Then we have settings divided into two categories, basic and advanced. Many of these settings are already set during the starting phase of the machine, while other features are accessible by the operator. For example, RPM for our feed roller. Here we have another page, the advanced settings page. From this page, it is possible to turn off some controls in case of failures. Then we have an alarm page. Alarms are divided into two groups, primary and secondary. Primary are shown in red, and we're talking about alarms that stop the process because there's a risk of damaging different components, while yellow alarms are secondary alarms that are just about a warning for the operator And so, yeah, there are warning about less important or severe anomaly. In this page, you can see the state of all the different alarms. In this case, no alarm is active, but if we had an alarm going on, there you could see the LED on, and then there's also a reset alarm button. Then the second part of this page is about a register of the events where you can record all the primary and secondary events that occurred within the machine. Then we have a calibration page. In this version, we only have level calibration. In this page, we will associate the 420 milliampere signal to a percentage value from 0 to 100. There we have a statistics page, which is useful for operators to assess the functioning of the machine. So we have, for example, the engagement count and the hopper warming time in the last 2 hours, and this is useful to assess how the product reacts in the hopper and especially in the roller mill in this case. Then we have statistics about the functioning or running hours of the roller mill, and then the average energy consumption. Then the maintenance page is useful, especially for technicians that want to analyze the functioning of the machine. In fact, we can see different kind of data, for example, the absorption of the motor that we could see even in the runtime page, but there's also the electric signal for 20 milliampere signal of the transformer, which measures the absorption of the milling motor. The same happens with the level probe. On top of the percentage, we can also see the analogic signal that the controller on board of the machine receives. In this case, we're talking about a 420 milliampere. We have information about the state of the machine. So if we have a primary or secondary alarm and other kind of information like the presence of the product or authorizations, sensor state, etc. Now we can move on to the test phase. On this page, we have two tests available. One for the gear motor. You just need to press the button and this will start. So the feed roller will start. So you can see that the gear motor started, and thanks to the belt, the feed roller is put into rotation. Now we can also test the pneumatic cylinder, which manages the movement of the milling cylinders. You can see this symbol, this icon of a valve. In this case, you can activate the electrical valve that will control the pneumatic cylinders. And this is the movement from the pneumatic cylinder. Okay, I will leave the floor to Nicola for your questions. Thank you, Ivan, for your demo, and thank you, Luca, for all the information you provided us with. Now I will leave. I would devote some time for the questions that we will get through the chat. So let's start with the first question. So they're asking us whether So this is for Luca. Luca, can you talk a little bit more about the controller? So I can give you a sort of demo. So let's imagine that within a plant, the controller has a QR code that will allow the activation of the motors of that plant. The operator will have to get into the page of the mobile controller. In this case, we don't have it on the demo. So they just need to scan the QR code, and this way he can open a list of the motors that he can control. So starting from here, he will be able to give different kind of signals or commands. For example, start and stop signals for diagnostic purposes. Thank you, Luca. And a question for Ivan. How can you change the feed roller speed? So the feed roller is started by a gear motor, as I was saying. This gear motor, which works with a mechanic reducer, is started by an inverter that guarantees the control of rotation and on speed, acting on tension parameters. Okay, thank you. So we can see that you have a tablet, but I would ask one of you if this Mobile system is available for smartphones or other kinds of devices. Mobile was conceived to be adaptable to different kinds of screens or devices. Within the implant, there is a backup system in case all devices are dead, so there's no more battery. And there's also a version for computers from the control room. So from this version, we have developed different versions. In this case, we have an 8-inch tablet. Smartphones nowadays get to 6.5 inches. But anyway, this system is adaptable to smartphones anyway, as well. And thank you. They're also asking us if tablet can carry out different other different functions. For example, starting or stopping the 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 operations in the tube. So is it just about roller mills or are there other functions? So far, the functions are about controlling the machines and motors. At the moment, this system does not replace the control system of the plant. We're talking about two different things. Of course, we can manually check some motors from the different groups and lines within the plant, for example, cleaning, milling, so all the different motors. They're also asking if there is a temperature control system. For roller mills, yes. So there is a system to check temperatures, not in this version, but for different machines, we already set up some temperature probes, both on the bearings from the rollers and on the rollers. So we usually place them on the machine in case the clients want them. And is it possible to have some information about the motor maintenance or temperature, information about temperature from the tablet? Are you talking about roller mills? Yes, but also other machines. Yeah, there are statistics about the motor. So from these statistics, we could plan an intervention or a maintenance action. in this device, can it be downloaded on Ocrim devices, or can people actually use it on new generation roller mills, for example? So the application was developed according to our version of roller mills. So it was created to communicate with the Ocrim controller. So at the moment, you cannot really use it for other systems or machines. They're also asking, well, thank you first of all for your answer, but they're also asking if you can talk a little bit more about the gap between the two milling cylinders. So through this adjustment component, it is possible to open or close the two milling cylinders in this manual version. You just need to rotate this little handle, while there is also an automatic version that, thanks to the use of two small motors, one for each side, without acting directly on the machine, but just using the touch panel or the tablet, the operator can select the distance that he desires. So are you talking about the automatic version of RMX? Yes, I am. Are there any more questions? It might be interesting actually to talk further about alarms. Yeah, we could analyze every different alarm. I can show you the screen. So talking about secondary alarms, in this version, we have two secondary alarms. One is hopper overload, which is about the maximum level of product within the hopper. This limit can be set by the user. And a similar one, which is about the absorption motor overload. Then, talking about primary alarms, we have two controls on the position of the pneumatic cylinders. So rolls engagement and rolls unengagement. And thanks to the sensor that I showed you before, we can monitor the right movement of the pneumatic cylinder, and so the distance between the rollers. Then we have a no-run feedback from inverter, which is about an anomaly from the inverter that activates the gear motor in case there are problems with energy supply, etc. So the controller would be noticed. Then we have feed-in rolls, which is about a problem about the rotation of the feed roller, thanks to the RPM controller. And then we have the RPM motor alarm, which is still about rotation, but this time about the rotation of the milling cylinders. Thank you, Ivan. I would leave I would now move on to the last question. They've asked us something similar this morning. So the tablet device, does it need to be connected to a Wi-Fi network, or can it work offline? Well, Mobile was conceived to be used also offline. The vast majority of plants in this kind of plans, people don't want to use Wi-Fi connections because of safety reasons. So I would say that 8Mobile works perfectly well even offline. Okay, I will join you. Thank you so much for your answers. And I think hearing from you was very interesting, or even for our audience. So before we conclude our event and before I move on to acknowledgements, I would like to remind you that if you have further questions or doubts, you can always send us an email at conferenceroom@ocrim.com. And it will be a pleasure for us to answer to your questions. I would invite you to fill out the survey that we will use to get a feedback from you so that we can improve this kind of events. And I would like also to thank our simultaneous interpreters. Thank you, and I'll see you at our next event. Last thing, you can subscribe to our newsletter to get updates about our events. Thank you and see you next time.